All right, you guys are going to hear me talk about operations quite a bit, and I just want to go over the operations so that we truly understand them in their most basic form. So our operations are add, subtract, multiply, and divide. So a lot of times when I see the word operation, I'll go ahead and I'll put some symbols by it just so, add, subtract, multiply, and divide, just so that I remember, or you guys should do this so you remember that that's what that means. Pick an operation, do something, add, subtract, multiply, or divide, and figure out what it's doing. Now, when we add things, adding has to do with bringing things together. So we put things or items together. Things or items together. Subtraction is taking things or items away. So if ever you're trying to find out how much more or less something is, that's going to be a subtraction. Find how much or less of something. That's you're gonna do the operation of subtraction. Multiplication, whenever we're multiplying, it's actually repeated addition. So what's happening is you're putting the same number of items in over and over and over again. So, the same number of items together over and over again. However many times you put them over, that's really what you're multiplying by. So if I have 4 markers and I put 4 markers in groups and I have 6 different groups, well then I have 4 times 6 and I have a total of 24 markers. So that's really what it is. You're just repeating that same number over and over and over again. And so however many times you repeat that, that's why you do that multiplication. If I wanted to take the long route, could I just add 4 6 times? 1, 2, 3, 4, 5. Yeah, I could. Means the same thing. Division, so when we divide, it's actually repeated subtraction. I am taking things away in the same size of group over and over and over again. Things or items away, whatever we're talking about. The idea of this is like, if I have, let's say I have 21 candy bars, and I want to group them, I want to give 3 of them away to each person that comes through. So I am giving them away in groups of 3. So 21 divided by 3 is going to be, I can give a total of 7 people 3 candy bars each. So I could also do it like this, repeated subtraction. So minus 3, minus 3, minus 3, minus 3, minus 3, 1, 2, 3, 4, 5, 6, 7, and that is going to get rid of all of what I had. And so that's really how you would do that division. We had 7 times that we could give those 3 things away. Hopefully that makes a little bit more sense. Now what I want to do is I want to go over a couple of story problems and we're gonna walk through them so that you guys can understand how you need to be thinking about them. So this first one, it says, Jed reads P, and if ever they tell you what variable to use, then make sure you pay attention to that. In this case, they told us P, all right? So Jed reads P pages each day of a 200-page book. They want us to write an algebraic expression. So we are not going to solve. We're not going to find out how many days it actually took him to read the book. We just have to write the algebraic expression, and then we could solve if ever we found out what P was. So what we are doing is, this is what we don't know. That is our variable. Sometimes it's easier to work with a variable if you substitute a number in. So a lot of people don't like to think about variables as this unknown. So they'll be like, okay, instead of reading an unknown amount of pages each day, let's say he read 10 pages each day. So the first day he read 10 pages, the next day he read another 10 pages, the next day he read another 10 pages. So if we're working backwards, you can see that we need to start with 200 and take away how many pages he did each day. You see that? So if we had 200, we would take away P for the number of pages. We could do 10 right now because that's kind of what we're substituting in for P. And then we would take away 10 for the next day of pages, take away 10 for the next day of pages, take away 10 for the next day of pages. And then after you did that, you could find out how many days of pages he actually read until he was done with the book. So in our operations over here, we see that this is our dividing. We are repeatedly taking away a number from what we start with. So we need to take 200 and we need to divide it by however many pages he read. Now, he didn't read actually 10 pages, so that's why you have to put this P in, because we don't know what he read, and so that's what this actually stands for. So this is your expression. We know that this is our expression. If you wanted to even make it a little bit more clear, you could say total number of pages divided by pages each day. So the pages he reads each day. Hopefully that helps. This right here would be your expression. All right. We're gonna do one more. I'm gonna bring it in. Set that right over there. I don't know if you can still see all of that. Okay. To rent a certain car for a day costs $84 plus 29 cents. If you'll notice, I have my dollar sign, I have 0.29. So plus 29 cents for every mile the car is driven. It wants us to write an algebraic expression. So once again, we're only writing an expression. We don't actually have to find a nice, neat number for an answer. So write an algebraic expression to show how much it costs to rent the car for a day. All right, just to get the car, that first thing that you have to pay is this. You have to pay that $84. Now, the minute we drive it off the lot, we pay 29 cents for our first mile. Do you guys see that? So first mile is 29, second mile is 29, third mile is going to be another 29 cents, fourth mile. So we will keep on adding 29 cents for every mile. So if you notice, if something happens one time, it is going to be without a variable. So $84 happened one time. Now this 29 cents is happening over and over and over again. So when I am making my expression, I know 84 is gonna happen one time, and then depending on the number of miles I go, I have to pay 29 cents for every mile. So because I don't know how many miles I'm gonna travel that day, that's why your variable is that M that's connected to the miles. If I only go 10 miles, I don't know why you would rent a car to go 10 miles, but let's say I did. If I only went 10 miles, then that means I pay $84 because of the fee to initially take the car, and then $2.90 because I went 10 miles. If I went 100 miles, I would pay, so this is 10 miles. You would substitute your 10 right in here, and that's how you would get your your $2.90. If I went 100 miles, I would substitute that in for my variable. And the reason why I pick 100 is because it's easy to move that decimal over. So then 84 plus $29. So that mile is what's changing, and the fee that's connected to it is going to tell you how much you have to pay for that. So if it's happening over and over and over again, that's going to be connected to the variable. All right, I'm gonna have you guys do 2 of these so I can see if you're understanding how it's working, and we will see you tomorrow in class.